Flex is very powerful. Oh, I don't know if it can beat the most powerful operating system ever created that even fits on ROM cartridge. Okay. Press any key to continue. Hi everyone, for this week's video I have a few different updates on a few different topics related to Flex. I don't really have big project update. I will have more things coming for Flex obviously, and I'm just sort of giving a review of the things that have changed since last week. So the first thing I want to cover is finally the Flex disks that I uploaded to the Color Computer Archive are here. You can see the extended basic, the editor, and the color utilities disk, and the actual Flex operating system. If you go search for Flex, and you can see those disks here. Here's the editor disk, and the operating system disk, Color Flex 5.0.4. This is the one that was just uploaded to the Color Computer Archive. So if you want to go here to get that, it's now available on the Color Computer Archive, as well as on the Internet Archive.
Warning, technical content ahead.
In the past week, I actually figured out why Flex was not working in MAME. And so I have here the merge request that I gave to the MAME project. What I actually figured out was because Flex actually requires having single density on track 0, I found out that this actually was not working in MAME, and I figured out why. We have to actually look at the schematic to understand why this is the case. So this is the schematic of the FD502 disk controller. And if we look at it, there are two different things going on here. This signal here, double density enable, this is an input to the controller. So this is a set of latches. When you write to the drive register, I believe on FF40, you actually set the latches in this latch. And bit 5 is the one that's actually the double density enable. So if you look at where this goes, we said that this is a controller input. So it's the purple line here, it goes here. It is covered up by the highlighting, but there's actually a dot here. This line from here and this line here both connect to each other. So this is an input to the controller, telling it to enable double density. Okay, and it also goes into this NOR gate. You want to note that there's actually no dot here, which means this line and this other line, interrupt request, which is an output, these two lines do not connect to each other. The purple line and the yellow line do not actually connect to each other. So we talked about the double density enable. What does the interrupt request actually do? The interrupt request is an output. You can configure the floppy controller to generate an interrupt when it is finished with the operation. For example, if you're writing all the data for a sector or writing all the data for a track or something, the controller will send an interrupt request when you've gotten to the end of the operation. So let's look at what's happening with this output. This output actually does two things. There's the yellow highlighted part, and there's a second part which I did not highlight at all. Okay, let's look at the yellow part. So this actually goes into this flip-flop over here. 74 is a flip-flop. So what's this flip-flop actually doing? The output of this flip-flop, if you follow the yellow line around here, is the halt signal. Because the halt signal actually is used in the color computer. The color computer is halted while the controller is preparing data, and when the data is ready, it will clear the halt signal, and then the computer is in a very tight loop. It will read the next byte of data from the controller, and then it will be halted again, and this will continue over and over and over again until you get the interrupt signal. So this interrupt signal clears the flip-flop, which basically clears halt. So every time the operation in the controller is finished, the halt signal is removed. Okay, so this is what we see in the schematic. So there's a second thing that the interrupt request actually does, and I did not highlight this part of it, but if you look here, the interrupt request goes through this OR gate and this line, which is not highlighted, but that generates an NMI. So this line here, which is not highlighted, actually is the one that generates the interrupt that the computer gets. Okay, so this is our review of the schematic. Now, if we go back to the MAME code, the actual code here, I can actually show you what was changed. So the left side is the original code and the right side is the modification of it. What you have on the left side is if the controller is sending an interrupt request, and there's this second part here that says disk register 20. Now hang on just 1 second. Something doesn't look quite right here. Let's understand what's going on here. So this is the disk basic unraveled, and they very clearly explain what's going on with these registers that are FF40. So it said bit 20. So let's go and find that. So here's 08, here's 10, here's 20. Density flag. Okay, that seems interesting. We're talking about the interrupt request. Why does that have anything to do with the density? You can see that they are actually connected together, the interrupt request and the double density, through this OR gate, and this controls the NMI signal. So let's see how that looks. We have the double density enable, or we have the interrupt request, both here. So is this actually what we see in the code for setting the NMI? And we basically say the NMI is set if you have an interrupt request and if you have double density. Well, the NMI is only sent if you have double density. Okay. This doesn't really seem to match exactly what you see in the schematic, but there's a little bit more going on here. If you see all these NOT gates, and this is a NOR gate, and there's a NOT gate here, this actually does turn into an AND if you go through the logic. So that looks fine. This is double density enabled and an interrupt request, fine. That part looks okay. But the part that doesn't look okay is this part right here. Clear halt enable under certain circumstances. So what this code actually says is if you have interrupt request and double density is enabled, then you actually clear the halt. So this code is a little bit different than what you see in the schematic. But again, we're talking about the yellow line. If you have interrupt enable and double density enable, well, we already explained These two things don't connect to each other here. This is a reset signal. This is not double density enabled. These don't connect to each other. The code says interrupt request and double density enabled. There's no connection here. These don't connect to each other. So this part of the code is wrong. What it means is that this interrupt is supposed to work anytime the controller says, I'm finished with the operation, it's going to send the interrupt. But there's an extra condition here, which is actually not shown in the schematic. So this interrupt is not generated if it's in double density. And if Flex needs single density and it depends on this interrupt request coming in on NMI, then it won't work. So the fix is basically just remove that condition because that condition is not shown in the schematic. So that's my fix. So after you make this fix, then you can run Flex in MAME. And I can demonstrate that very, very quickly. Alright, so I'm going to do the demonstration that Flex actually works inside of MAME. This is one that I built myself with the source code changes that I made. Again, it's not publicly available. If you build MAME from the latest source, then you can actually get this change. So this is the package that is on the Internet Archive, as well as the Color Computer Archive. So this is the Color Flex 5.04, and we're interested in this DMK file right here. Okay, so I'm going to run my compiled version of MAME, and these options, no filter and no stretch, these turn the kind of horrible softening of the picture, turns it off. And I use a CoCo 2B, and we're putting the DMK file in there. So let's go ahead and run this. So far so good. It looks like a normal CoCo. Let's do a directory. And there's Flex. And again, as I have demonstrated many times, the way that you run Flex is you don't type DOS. It doesn't auto boot. You have to type run Flex, and this actually does the loading. Okay, Flex is booted up right now. We just have to type the date. Let's see if I can get it wrong this time. And so what happened before from this point, before I made the fix, was that it actually hung. It didn't actually completely boot up. So this is Flex completely booted on MAME. And we can do this other favorite useless test of just typing the directory, just listing the directory. Yeah, so I'm not going to demonstrate more. I just wanted to show that this was actually working and that this will be coming soon to MAME. So I want to say one more thing about this MAME fix before we move on to the next topic. I made this fix this past weekend. It says 4 days ago. Today's the 15th. That's the 11th. That was over the weekend when I did this. And currently, MAME is on a bi-monthly release schedule. They don't release every single month right now. Previously, they were doing releases every month. Now they're doing it every 2 months. So they do have a release in April, and they have a release in May. They may have a release at the end of June. I'm not sure. March, April, May. Looks like they're doing updates every month now. So I don't know exactly when this is going to be available for the general public. It's either going to be sometime around the end of June or possibly sometime the end of July. I will keep eye on this, and when this is updated and released to the public so that you can just simply download it, I'll send an announcement on the channel to that. Also, of this past weekend, I remembered that somebody told me that they had a version of Flex on the Dragon computers. And this is actually called CompuSense Flex. They have all these different Flex disks from CompuSense. And I didn't know exactly where to find all of these. And over the weekend, I was sent a link by MikeyN6IL's, and don't like this view. Let's change it to list view. So these are all of the CompuSense Flex disks that have been archived. I have not gone through all of these yet, but I have started looking at some of them. I know for a fact this utilities disk is pretty interesting and useful. They have Super Sleuth. Not sure what this editor is. Can check that one out. Some database program. Here's Flex itself. Editor assembler, extended basic, Dynafast, Dynacalc. Some interesting stuff here. So I plan to go through what's here, check it out. I will make an individual video about this. But the one thing that I am going to show is I am going to show this in operation. So let's go ahead and do that now. So as I showed before, I downloaded this package right here, Flex System 1.3.2 from CompuSense. So this is the package that I downloaded. This is the contents of the package. It just contains Flex 1.3.2.vdk. And we just go ahead and run that. I'm running Xtor, telling it to run in full screen, and I'm just attaching this disk image to it. So let's go ahead and run this. All right, now if you try to do a directory of this disk, it doesn't work, but it does actually work. So in Dragon DOS, you don't type the DOS command to boot things, you actually type boot. There you go, Flex copyright CompuSense. Here's this pesky date prompt again. It's still the same. See if I can get it wrong. Okay, looks like I'm getting it right. Wow, they're so polite. Welcome to the Flex operating system for the Dragon 64 computer. Flex is versatile and elegant, and you will find it a positive asset in your computer armory. I have a computer armory? Wow. Flex is very powerful. Oh, I don't know if it can beat the most powerful operating system ever created that even fits on ROM cartridge. Okay. Press any key to continue. Oh. Yeah, they tell you how to do all this stuff. Yeah, the terminal driver in this version of Flex is a little bit more fancy than the one that comes in Frank Hog Flex. It has like windows and stuff. I'm not going to ask for the demonstration. And yet again, going to run my favorite useless command, disk catalog. So we don't have smooth scroll here, so yeah, it's a little bit faster, but this is pretty much equivalent to what you have on the CoCo. So this disk has a lot of interesting things in it. I'm going to get into the details of this in another video when I do a more full introduction to this. But I just found this, so we have yet another version of Flex. Alright, this is what I wanted to demonstrate today. Kind of a potpourri of a few different items. The fact that Flex works correctly in MAME now, at least for the color computer, and that I have found another version of Flex for the Dragon. So yeah, more Flex stuff coming. Bye, everybody.